We're going to work a few different varieties of quadratic form equations here in this video and the next video. And here's the first one. 2x to the fourth minus 7x squared minus 4 equals to 0. And it's a fourth degree polynomial, but it's quadratic in form. And what do we mean by quadratic in form? I want to make sure that gets into your head here. A quadratic form means I have something squared. In this case, 2x squared is squared, minus 7 times that same variable, minus 4 equals to 0. So in other words, if I think of x squared as my variable, then I have this variable term squared. I have a variable term to the first power, and we can have a constant. So it's something squared minus something, and then a constant. That's a quadratic form. And in fact, this because I designed this problem, it lends itself pretty well to solving. We can factor this equation provided we concentrate on factoring with x squared. So let's see if we can split this up into binomials. And in order to get 2x to the fourth, I need 2x squared times x squared. So these multiply together to get this first term. As far as what numbers go here, 4 will break up as either 1 times 4 or 2 times 2. If I put 2's here, then I'll get an even number from my middle term when I multiply back. And that's not possible. So it'll have to be 1 and 4. If I put 4 here with the 2, that means I could factor a 2 out. And we can't factor out 2 originally. So we have to have 1 times 4, and 1 has to go in this part, 4 has to go there, if this is to be factored. And let's see, from here we've got the outer terms are 8x squared and 1x squared. In order to get negative 7, I need the a minus 8x squared and a plus 1x squared. Finally, 1 times negative 4 is negative 4. So it's been factored correctly, and we can factor this further. In fact, you could, our solution of solving is to set each factor equal to 0. And so I have 2x squared plus 1 equals to 0. X squared minus 4 equals to 0. And we can choose to solve this by factoring it further. X minus 2 times x plus 2. Or we could use a square root method to solve that equation. Over here, looks like I'm going to get imaginary numbers, or complex numbers. So if I subtract 1, divide by 2, I've got x squared equals to minus 1/2. And so when I solve here, I'll take the square root of both sides. X would equal to plus or minus the square root of negative 1/2. Over here, if I set these equal to 0 and solve, then from this equation I'll get 2, and here negative 2. So you get x equals to 2 and negative 2. Alright, so we have solved it, and let me finish it because it's really not quite finished. We don't write complex numbers this way. We always factor the I out. So I'm going to write out the answer so it's clear. Having run out of board space, I'll just have to erase up here. So our answer would be 2, negative 2, and the square root of, let me put the I in front, again, because I like to show it that way, because sometimes people will, when they're learning this, will put the I inside the square root and it doesn't belong there. I times the square root of 1/2 and negative I square root of 1/2. So there we go. There's our 4 answers, and actually we got 4 because we had a fourth degree polynomial. So you can have up to 4 answers in those. That's a topic we're going to explore in a later chapter when we study polynomial equations. But anyway, this was a quadratic form, and there it is. So let's do another problem here. Our next example involves fractions, and I'll read it. 1 over x plus 3 quantity squared. When I say quantity squared, that means it's in parentheses and it's been squared. Minus 7 over x plus 3 minus 8 equals to 0. All right, now this will turn out to be a quadratic form. And what is our base variable? Well, it will turn out to be the fraction 1 over x plus 3. But before I go down that path, let me just point out that this problem could be worked a different way. We could clear the fractions by multiplying each part, each term, including that 0, technically, by multiplying each part by the common denominator, which is x plus 3 to the second power, the highest power of this term. That would clear the fractions, and then we'd have to expand it out. But it's a quadratic equation, and it'll work just fine. So there's nothing wrong with doing it that way. In my judgment, I think it's going to be a little more tedious than what I'm going to show you, but you feel free to disagree on that. All right. So I'm looking at it as a quadratic form because I see a denominator x plus 3. It's squared here, first power, and then there's a constant term. So if I think of this in this light, let's think of it this way, as 1 over x plus 3 squared minus 7 times 1 over x plus 3 minus 8 equals to 0. So here you see that if this is my base variable, as I call it, we have a second power, first power, and a constant of that same variable. So what I'm going to factor with is 1 over x plus 3. So we'll set it up so that we factor it into binomials. And again, when we multiply these, we're going to get this term, 1 over x plus 3 squared. 8, we need to break up 8 so that the factors will either add or subtract to negative 7. And it'll have to be 1 times 8, won't it? So if I put a 1 here and an 8 there, in order to get the minus 7, I need negative 8 plus 1 to get minus 7. All right, so and you can check it's been successfully factored. Very easy to verify that. So we set each factor equal to 0. 1 over x plus 3 equals, plus 1 equals to 0. And 1 over x plus 3 minus 8 equals to 0. So now we have two little equations to solve. And I'm going to need some room here, so I'm going to erase off the middle part in order to have that room. By the way, this problem, because it has fractions, we have to be careful about getting a fake answer, a wrong solution, because anytime you solve a problem with where variables appear in the denominator, there's always a little danger that you can produce a false answer. We've seen this before in the first section of the book. Now, we didn't need to check for that type of problem in the previous problem I did with the 4th degree polynomial, because those solution methods do not introduce any possible bad answers. There's no weakness in those solution methods. Well, in any event, let's solve this. So if I bring the 1 over here, I've got 1 over x plus 3 equals to minus 1. And if I bring the 8 to the right, I've got 1 over x plus 3 equals to positive 8. And I'm going to probably make it simple. Let's just clear the fractions on each equation by multiplying both sides by x plus 3. So on the left, this clears the fraction. I have 1 equals to negative x plus 3. Here, it cancels. 1 equals to 8 times x plus 3. So now it's starting to look a lot more friendly here. 1 equals to negative x minus 3 when I distribute to negative. And let me go ahead and finish that one first. So let me see, if I add 3 to both sides, this will be a 4 equals to negative x. So x equals to negative 4. And over here on the right side, it looks a little better. 1 equals to 8x plus 24. if I subtract 24 from both sides, I get negative 23 equals 8x, 1 minus 24, negative 23, and then divide by 8, and that gives us the answer 2. So let me write both these answers out. X equals to negative 4 and also negative 23 over 8. So there we go. Now, both those are, I'm pretty sure, good answers. We could check them to be certain, but neither one of them will cause division by 0. The only problem we could have encountered in that respect is if I had x equals negative 3 as an answer. That would have created one of these false situations. All right, so there we go. It's a quadratic form, and we're able to factor. You might reasonably ask, well, what happens if you get a quadratic form and you can't factor it in any way? Then there's always a quadratic formula. So I think your textbook may have slipped one or two of those in there, and I'm not too wild about those problems. I think you got enough to do to learn how to handle these quadratic forms. But the idea is valid. If you have a quadratic form, then we can use all the techniques to bear on it that we know about quadratic equations, including using the quadratic formula if we really need to.